One of the greatest inventions of all times is our transmission and distribution grid. It connects electricity generation to electricity consumption safely, reliably, resilient against extreme weather conditions, and keep our lights on. But if we were to facilitate electrification of everything, this most sophisticated and largest machine on Earth is not quite large enough to take on all the renewable generations from where the sun shines and the wind blows to where people actually live. It does not have the capacity to handle the two-thirds energy that we consume, not yet in the form of electricity. Without transmission, we have no transition. The real bottleneck in our power grid is actually the conductors. Those wires that are carrying electron are based on outdated technology invented in 1908. It has limited capacity and also poor efficiency. The next generation of advanced conductor exists. It has been invented, leveraged in the best material science today has to offer to build the best conductors. This is what the company I co-founded, TS Conductor, is working on. It can triple line capacity at the same time reduce line loss by 50%. The best part is it comes with a green discount, saving utility and their customers money from day one. There aren't many things in our lives that are over 100 years old. So why are we still using and relying on those old-fashioned power lines? This is because our utility companies are regulated monopolies with a very conservative culture. To understand today's advanced conductor, let's take a look at yesterday's wires. The original century-old technology, ACSR conductor, which is still dominant today in our power grid, it has steel wire as a core for structural support and layers of aluminum for electrical connectivity. The steel wire at the time, 100 years ago that is, wasn't strong enough. So we had to use hard aluminum for strength contribution. The problem is hard aluminum cannot handle high temperature. This limits capacity. In the 1970s, our steel industry was able to deliver stronger steel, which then can be combined with annealed aluminum. That forms the ACSS conductor, which is capable of high temperature operation for high ampacity. The problem is steel expands when hot. This causes excessive sagging. You probably have noticed that our power lines drooping in a hot summer day, and that's why. This sag causes its own set of challenges. In the 1990s, advanced conductor emerged. Instead of the steel core in the traditional conductors, composite material with lower thermal expansion, such as ceramic fiber composite or glass carbon fiber composite, are used to replace steel and reduce sag. Unfortunately, our utility industry experience with this group of first-generation advanced conductor hasn't been positive. They are known to be delicate, difficult to work with, easy to break, with longevity concerns, and they are also very expensive, used for niche applications at best. By 2016, TS technology was developed and commercially deployed. We solved all the problems associated with the first-generation advanced conductor at its source. We designed in safety, reliability, longevity, easy installation and maintenance from the start by leveraging effective protection for the pre-tension carbon core with a continuous, seamless, a thick aluminum sleeve that is also fully conductive. This technology shifted 3 conductor paradigms. We can run these conductors at high temperature for very high ampacity without conductor sagging problem. because the carbon core has virtually no thermal expansion. We also maximize the aluminum content in the conductor for optimal ampacity without the weight penalty in the conductor. This is because the carbon composite core was able to eliminate 80% of the weight of steel. And we can also incorporate the annealed aluminum for best conductivity in the conductor without compromising on conductor strength, because the carbon core is twice the strength of steel. And furthermore, this solution is also corrosion-proof. The heat-tolerant, sag-proof feature in this solution makes it much better in terms of surviving wildfires compared to traditional conductor. The strong and compact design also make it more resilient against extreme wind or ice storms due to climate change. Doing this, we can triple line capacity with the same structure in the power line corridors. At the same time, we can reduce line loss by 50% while essentially eliminating thermal sag. And the best part is, this technology comes with a green discount in addition to green dividend that's associated with line loss reduction. This saves the grid operators and their customers money from day one, even though this advanced conductor has a modest premium compared to traditional conductors. Here's how. When you build new transmission lines, the cost of conductor in the overall project is very minor, about a few percentage points. But the cost associated with structure can be as much as 30%. With the strong, less sag TS conductor, you can build these new lines with fewer and shorter structure, creating substantial capex savings that more than offset the modest premium associated with conductors. There are numerous new transmission lines deploying TS technology that can prove this point. In reconductoring, we replace the wire but reuse the towers. There's even better economics in that situation. We can triple the line capacity without retrofitting any structures for the lowest project cost. If you were to use traditional conductor for reconductoring, the required upgrade to the structure can be substantial. Let me give you a real-world example. In March 2021, we reconducted a 11-mile, 230 kV transmission line in North Dakota. The utility needed to increase line capacity to accommodate wind farms in the area. So the traditional conductor ACSS was initially used, which required expensive and time-consuming structural retrofit to 90% of the structures because of excessive sagging. When they later switched to TS solution, they were able to save 40% in total project capex because we avoided all the structural retrofit. The project was completed 12 months ahead of schedule with $1.8 million capex savings. Let's imagine what is possible if we thus upgraded our power grid and its capacity around the world. We could connect the renewable generation instantly versus the years-long wait that we're experiencing today. No more bottlenecks that's holding back wind or solar projects. We can electrify everything and meet the growing power demand for electric vehicles, heat pumps, industrial process, and data centers without grid reliability or transmission congestion constraints. Here's a big one. We can dramatically reduce greenhouse gas emission. Just with the reduced line loss saving alone, we can avoid as much as 500 million tons of greenhouse gas each year because we do not have to do as much compensatory generation. Add to that the multi-gigaton opportunity if we are able to connect so much more solar and wind to the world's power grid. you can make it happen. For example, you can support legislation, policymaking, and regulations that require our utility companies to consider advanced conductor in transmission, reliability, decarbonization, or grid modernization planning, while at the same time providing performance or other incentives that are enabled by new technology like TS so that they can improve grid performance by investing in this technology. Conductors have a design life of 50 to 70 years. Let's upgrade our power grid, build it better for a clean energy future today. We cannot afford to have another 50 to 70 years locked up with century-old technology in our power grid. I believe firmly that our power grid can and should be the enabler for energy transition. We have an opportunity to write that legacy. We went from dial-up internet to 5G in a couple of decades. We can do the same for our power grid. We just need to start now with the right conductor technology available today. Together, we can make a difference for humanity and for climate change. Thank you.